we have this object on a frictionless curve here, coming to this part that has friction with mu k, and then slows down, goes possibly that way, and goes back and forth until it stops. We want to see how far from the left side of this flat part is eventually going to stop. So because when it gets here, it goes up here and then comes back with exactly the same speed because there's no friction here, then we can say we can let it go all the way until distance d, where it stops. The distance d from this beginning of this flat. We find this d and then see how many times d is greater than L. Then from there we can find out where it actually stops. So we take this as initial situation, this as final. And in order to be able to measure potential energy, we need a y-axis. We put y-axis, y equal to 0 at this level, going up. So at this final situation, y final is 0. And because it stops here, right, v final is also 0. And initially, also v is 0, the initial. And the y initial is what?
H.
Is h. So we apply conservation of energy, say ai plus ui plus w of non-conservative, which is friction, equal to kf plus uf. Which one of these are 0?
The right side.
Kf is 0. Uf is also 0 because gravitational potential energy is mgy. Y is 0 here. But this is 0. This is also 0. Ki
0.
is 0. So all we have is initial potential energy and work of non-conservative. So initial potential energy mgyi, which is mgh, and work of the friction is negative Fk, magnitude of friction force, times distance d, equal to 0. And force of friction is mu k times normal force. And here, normal force is the same as its weight, so mgh minus mu k mgd should be equal to 0. And then mg cancels, so you see that d will be equal to h over mu k. So if h is 60 centimeter, then d will be what? 0.6 meters over 0.3 is 2 meters. So d will be 2 meters. So it needs to go 2 meters on the horizontal surface to stop. But if L is 80 centimeters, means that it will go 80 centimeter and come back 80 centimeter, that's 160, then it needs to go 40 centimeter to stop. So the distance will be 40 centimeter. So this distance from here to here is 40 centimeter. There it stops.